So this will be a two-part lesson, two different videos in which I explain how to write the formulas and the names for ionic compounds. Now remember, in the last lesson we learned that ionic compounds are going to be between a metal and a non-metal. The metal gives up its electron or electrons because it has a lower electron affinity, and the non-metal is going to accept the electrons because it has a higher electron affinity. Now for you to know, when you're writing the formula for an ionic compound or naming it, the metal will always go before the non-metal. So to write the formula, I'm going to show you three examples here. What we need to do, our ionic compound needs to have no overall charge. And keep in mind, our atoms, when they go to form an ionic bond to have that perfect octet, they will become ions. They will have positive and negative charges. And so what I need to do is I need to make sure that when they combine together, they combine in such a way that they no longer have a charge overall. So there's a way to do this in your head and to try and figure it out. Or there's a cheat that I call crossing your charges. So this is how I always explain how to determine the formula for an ionic compound. So the first thing I need to do is figure out the charge for these two atoms when they form ions. So I've got sodium, which has a +1 charge. Okay. And I'm going to write 1+ just for my own sanity. And then sulfur, when it forms an ion, has a 2- charge. And here's how I figured that out. Remember, looking at your periodic table, these are metals whose charges I know. I know group 1 is always 1+, group 2 is always 2+, and group 3, the ones that are metals, are 3+. Then remember, we skip group 4, then our charge is going to be 3-, 2-, 1-, and then 0, because these will not participate in ionic bonding. Okay, so what I'm going to do is I'm going to cross my charges. So I take the number, not the charge, not the minus or the plus, just the number for each of these, and I'm going to make it the subscript for the other element. Okay, so what this looks like, this will become Na, the 2 will become the subscript for sodium, S, and then there will be a 1 here, but remember, we don't ever actually write ones. It's implied if you have no number that it will be a 1. So that's your formula for your ionic compound. We've done one already. Okay, let's do the next one. Aluminum and oxygen. So when aluminum forms an ion, if you look, it's going to be 3+ charge. Oxygen is going to be a 2- charge. If you look at the periodic table, I'm going to cross my charges, just the 3, just the 2. I ignore the plus and the minus. So the formula for this is going to be Al2 and then O3. Okay, so this is the formula for the ionic compound. I do want to do my due diligence and quickly show you why this is the formula and why I cross my charges. So aluminum has a 3+ charge, and there are 2 of them, which means overall its charge is 6+. Oxygen has a 2- charge. There are 3 of them, which means it overall has a 6- charge. And so the overall charge of aluminum oxide, of this compound, of this ionic compound, is going to be 0. Okay, let's do one more. Magnesium and sulfur. Magnesium is an alkaline earth metal, so its charge is 2+. Sulfur is in the same group as oxygen, so it's 2-. So when I go to cross my charges, this is going to become Mg2s2. And the question is, well, can I just leave it like this? And unfortunately, this is the only issue with crossing charges. The answer is no. If you can simplify your subscripts, like if I have a 2 and a 2 or a 2 and a 4, right? These are going to just become 1s because they can simplify each other. If it were a 2 and a 4, it would simplify to a 1 and a 2. So if you can simplify, you have to, but that's pretty manageable. Okay, so you have now learned how to write the formula for ionic compounds. Okay, let's talk about naming. It's not much more difficult than what we just did. When we're writing the name of an ionic compound, we're going to write first the name of the metal, and then we're going to write the name of the nonmetal. The only weird thing with this is that we're going to add an IDE ending. Okay, so let me show you some examples. Okay, so some of my nonmetals I could have nitrogen. I'm going to get rid of the ending for nitrogen, the -gen part, and I'm simply going to make it nitride. Okay, oxygen. I'm going to get rid of the -gen part, and it just becomes oxide. Another example, sulfur. I'm going to get rid of the part, and it's going to become sulfide. Okay, so you kind of get the picture. All right, so let's do some practice. I give you Li2O, so I'm going to name this. So I first just need to put the name of the metal, which is lithium. Okay, and then my nonmetal here is oxygen. So it's going to be, I'm going to start to write oxygen, but I'm going to add an IDE ending to it, so it's just going to be oxide. Okay, calcium fluoride. I now need to write the formula for calcium fluoride. So I need to figure out the charges and cross my charges just like what we did up above. So calcium, if you look at your periodic table, it's a group 2 metal, so it has a 2+ charge. Fluorine is a halogen, so it has a 1- charge. And so when I cross my charges, the formula for this compound is going to be Ca. I'm not going to put a subscript 1, just CaF2. All right? Let's write the name for the next compounds, CaS. So it's going to be calcium. The nonmetal was sulfur, so I'm going to add an IDE ending, so it's going to become sulfide. Okay, and for the last one, aluminum oxide. Aluminum has a 3+ charge. If you look at the periodic table, oxygen has a 2- charge. And so then this becomes, and we actually already did this problem up above with just aluminum and oxygen, but now we can do it from the name itself of the ionic compound, Al2O3. Okay, not too bad. We call these binary ionic compounds because you have 2 different atoms, binary 2. I'm going to slightly complicate things a little bit by introducing one more new concept, and that is polyatomic ions. So if you look at your polyatomic ions, these are ions that have more than one atom. So instead of just having oxygen oxide, for example, you have hydroxide, which is OH, okay? And the charge of OH is -1. Ammonium is NH, subscript 4, so there are 4 hydrogens, and that entire molecule has a +1 charge. Nitrate is NO3, and its overall charge is -1. Nitrite is NO2, and its overall charge is -1. So as you look through these, the one thing that students tend to struggle with is being able to identify the difference between a subscript and a superscript. So if you look down at carbonate, what this is telling you is you have 1 carbon bound to 3 oxygens, and the overall charge of that molecule is 2-. Okay? You will be given this table. You are not expected to memorize your polyatomic ions. The one important thing for you to note, all of these polyatomic ions have a negative charge except for ammonium. Ammonium is the one weird polyatomic ion that has a positive charge. So if you think about it, that begs the question, okay, what if I have a compound that has ammonium in it with a nonmetal? Would that count as an ionic compound? And since an ionic compound forms when you have a positive and a negatively charged ion, the answer is yes. So you will see some examples where you don't actually start with a metal, you start with ammonium instead. But that's the only situation where you could start with something that is not a metal, is when you start with ammonium. Okay, so let's look at some examples and see how I name and write formulas with polyatomic ions. All right, the first one, I'm given NH4 parentheses 2O. All right, so as I had said, you can actually have an ionic compound that starts with just ammonium. So when I name this, all you're going to do when you have your polyatomic ions in an ionic compound is you're just going to write the name of the polyatomic ion as you go. So for this one, NH4 2O, this is going to be ammonium oxide because I have oxygen after it. Not too crazy. Let's look at the next one. Aluminum phosphate. So aluminum has a 3+ charge. Now I need to go up and look for phosphate. Okay, so I see phosphate right here. So phosphate, the formula for it is PO4, and its charge is 3-. So when I go to cross charges, I have Al3, PO4. Here's the one thing with polyatomic ions when you're writing formulas that you need to be careful with. If I just wrote a 3 like this, what that would look to me would be that I have 1 phosphorus and 43 oxygens. But I don't want 43 oxygens, I want 3 phosphates. So what I need to do is just put phosphate in parentheses, and I'm good. All right, so if you have more than 1 polyatomic ion, you have 2 or 3 or 4, then you need to put that polyatomic ion in parentheses when you're writing its formula. But if you only have 1 of them, you don't. So do notice, what I hope you noted, was that I have a 3 and 3 here. So I can simplify the 3 and the 3 here, and that will give me AlPO4. And notice I'm not putting my PO4 in parentheses now because I only have 1 of them. If it makes you feel more secure to put parentheses, you can, but I would not recommend doing that. Okay, it's just extra work for you. CaSO4. So Ca is calcium. And remember I said when you're writing the name using polyatomic ions, you just need to write the name of the polyatomic ion. You don't need to change the ending at all. So SO4 is sulfate. So it's going to be calcium sulfate. Okay, and for the last one, barium hydroxide. Barium has a 2+ charge. If you look up at your chart, hydroxide, which is at the top, has a 1- charge. I'm going to cross my charges like I did before. So this is a 2, this is a 1. So this is going to become BaOH2, but keep in mind because I have 2 hydroxides, I want 2 hydroxides, so I'm going to put this in parentheses. So that's my formula. One thing that students tend to do that gets them in trouble, one last note here. If I give you sodium sulfate, for example, a lot of students then want to simplify this by making this a 1 and making this a 2. And one thing that I note over and over, and I'll continue to note it, you cannot change your polyatomic ion, okay? SO4 stays SO4 no matter what, okay? Hydroxide stays OH no matter what. You cannot manipulate any of these subscripts and change them for your own convenience. They need to exist as they are. As soon as you get rid of the 4 from ClO, 4- for perchlorate, for example, you've completely changed the molecule. So as you're practicing, make sure that you keep your polyatomics written as they are given to you on your table.